Hello everyone, welcome back to this lecture. In this lecture, we'll discuss the immutability of strings. However, before diving into that topic, let's first demonstrate the assignment behavior of value type and reference type variables in VS Code. As you may recall from the previous lecture, when assigning a value type to another value type, the value is directly copied from one variable to another. For instance, let's declare an int variable named number1 with a value of 10. If we declare another variable and assign it with number1, both number1 and number2 variables will have the same value, which is 10. But they have separate memory locations, which means that if we change the value of number2 to 5, it won't affect number1. To illustrate this, let's display these two variables in the terminal. After running the application, we can observe that only number2 has changed to 5, while number1 remains unaffected. Alright, now let's demonstrate the assignment behavior of reference type variables. As you may know, when assigning a reference type variable to another, no actual data copying occurs. Instead, a new reference or pointer is created that points to the memory location where the actual data is stored. For example, let's define a class named player, which has two properties, name and jersey number. Then, we'll declare a variable named player1 and initialize it using the new keyword to create an instance of the player class. Next, let's assign John to the name property and 7 to the jersey number. Now, if we declare another variable and assign player1 to it, both player1 and player2 will hold the same memory location that refers to the actual data of player. So, if we change any of these variables, it will affect the other. For example, if we change the jersey number of player2 to 18, since player1 refers to the same data in memory, its jersey number will also be changed to 18. To illustrate this, let's display the jersey number of these two variables in the terminal. After running the application, we can observe that the jersey number of these two variables has changed to 18, while we haven't changed the jersey number of player1 at all. Alright, in C#, all instances of classes are considered reference types. This includes string objects, since they are instances of the string class. Let's illustrate the assignment behavior of string objects with an example. First, we declare a variable named myString1 with the value of Hello John. Next, we declare another variable and assign myString1 to it. Now, since they are reference types, if we change either of these variables, the other variable must also change. For instance, let's say myString1 equals boyjohn. Let's display these two variables in the terminal. Let's run the application and see what happens. As you can see, after changing the myString1 variable, the value of myString2 did not change. This is unexpected because strings are reference types and we'd expect that changing one variable would affect the other. However, the behavior we observed determines that strings are different from typical reference types and they behave like value types. But why is that? This is because strings are immutable. Alright, let's discuss what immutable strings mean. The term immutable refers to something that cannot be changed. In software development, an immutable object is an object whose value remains constant once it's created. This means that once a value is assigned to an object of immutable type, it can never be changed. In the case of strings, they are considered immutable objects. This means that string objects cannot be changed after they have been created. You might wonder, even though we can easily change the value of a string variable, why do we still consider strings as immutable? To gain a better understanding of string immutability, let's illustrate to you what exactly occurs during the process of string assignment. In the first step, we declare a string variable named myString1 and assign the value HelloJohn to it. Like our reference type variables, two memory spaces are allocated. One for storing the actual data, which is HelloJohn, and another for the myString1 variable that holds the memory location of that data. Now, if we declare another string variable named myString2 and assign the value of the myString1 variable to it, a separate memory location will be allocated for myString2. As a result, both variables will refer to the same data in memory. Finally, when we change the value of myString1 to byJohn, an important point becomes evident. Since strings are immutable and cannot be changed, the CLR does not change the original data, which in this case is HelloJohn. Instead, it allocates new memory space and puts the string data, which is byJohn, into it. Afterward, the memory location of the new string data is put into the myString1 variable. Now, as you can see, these variables no longer refer to the same data in memory. This is why these variables display different results. This proves that string objects are immutable because changing myString1 does not affect myString2. So, when working with strings, any operation that appears to change the string actually creates new string data in memory, while leaving the original string unchanged. In simple terms, when we say a string is immutable, it means its value cannot be changed in any way after it has been assigned. We hope the concept of string immutability makes sense now. Thank you for watching. See you soon.